Hello and welcome back to part 4 of this series of the 3D printer filament maker. Today I'm going to be going over the circuit that I've been building to control the heater and read the temperature and also control the motor. I just wanted to make this video to show how I'm doing the circuit. It's not very complicated, but if anybody wanted to make this project and didn't really know where to start, then this is the video to watch. Alright, so we're gonna get right into it. Here is the circuit diagram. I have basically everything laid out. The STM32 on the left there, that's the microcontroller I'm using. You see some ADC, which is when I'm reading the temperature. You see some PWM when I'm doing some PWM to either the heater or the motor, and then the ground, and then the plus 3.3 volts. So on the bottom left here, we can see that we have the R set, which is what we discussed in the previous video about the thermistor and how we're going to measure the temperature. We're supplying that with 3.3 volts, and then we have the thermistor there, which we have connected to ground. This is the same ground that's on the STM32. And then we're going to be reading this voltage out from our ADC, and obviously all of these pins are going to be changing if you're using a different microcontroller, but the basic idea will pretty much stay the same. So that covers how we're going to read the temperature. Next, we really only have two things, is how we're going to tell the heater block to either heat up or not heat up, which we're going to be using PWM for that. I have that as the middle circuit there. I'm using a FET module I got off AliExpress for really cheap, just because I wanted to try it out. I mean, this whole project is just to have fun, try out stuff, learn. It's powered by, I'm going to be using 12 volts DC because I have a power supply which I can use 12 volts for. And as input, it's going to take our PWM signal and then the ground of our STM32. These are pretty much the same between the heater and the motor. The only difference is basically the load that's on it, so the resistance, whatever. But one thing to note is that with these FET modules, they are isolated. And what I mean by that is that inside the module, they're like not electrically connected. So if there is an issue with the load or the power supply, then it won't blow up your microcontroller, which is pretty cool. How these ones work specifically is that they use this thing called an optio isolator, which is basically that the PWM signal I'm having as input is going to be flashing a light onto some sort of transistor, which is going to signal the power to go on the output of this. So electrically they're isolated from each other. So basically the rest of the circuit is just having the 12 volts power supply, and then that ground is to the power supply, not to the STM32. So you don't have to connect the grounds like that for this to work. And then just that the one connection goes to 12 volts DC and the other connection goes to the output of this FET module for these loads. So we'll see a little bit more about this later. So as I said before, I bought these FET modules off AliExpress, so I was just kind of testing them out. I ended up buying two different ones, so I had to decide which one I'm going to use for what. So one of them has to be used for the heater, and one of them has to be used for the motor. So I know that the heater is going to be using more power, so that more current is going to be going through it. So ideally at higher current we want less of power loss using these FET modules. So I pulled up the data sheet on both of them that they're using, and here we can see that on the left here on the IRLR one, at 1 volt drain to source, we can get about 120 amps, not exactly, but you know, and at 1 volt VDS of the AOD we can get about 100 amps, and this is using a VGS of 10 volts, but we're going to be using 12, so it'll be a little bit higher than that. But we can see that the IRLR can deliver more current for the same VDS, so that means that it'll have a smaller power loss than the AOD, so that this is going to be the one that I'm using for the heater module, which I don't know, they might be exactly the same because they are from AliExpress, but I'm going to be using this configuration anyway just to be safe. It's also important to note that you really shouldn't be using small VGSs for these, because as you can see, like, look at the one on the right. If you have a VGS of 3 volts, the VDS is going to be very large, so any current that you're passing through that is going to have a gigantic power drop, so the FET is going to get very hot and it's going to be very inefficient. So if you're doing this project, make sure to have a supply voltage of something that's decently high. They show 10 volts here, so I'm doing 12, so that should be fine. Alright, now that we got the configuration down for everything, this is just a picture of me starting to solder everything together. It's not perfect, but I'm just using a small breadboard, a couple jumper wires and whatever, just to get everything done. As you can see here on the left, there's a schematic, and on the right is the resulting wiring that I've done. These blue wires are the PWM there that we're going to be passing through to the motor and heater, and those there are the 2 FET modules that I'm using. The thermistor had a connector, so I just soldered in 2 pins basically just to get electrical connection there, and then all the rest of the wires on the bottom are ones that go to the STM32. So we got ground, the ADC plus 3.3 volts, and then on the top here is what I'm going to be doing with the power supply, the ground and plus 12 volts. So here's how it kind of looks when I finish it up. I put some wires in the output of the FETs, as you can see here, just to make sure everything works, everything connects well. Everything on the left of this breadboard is going into the STM32 device, except for this thermistor. I just have it going under it and around just because it's easier to orient the wire that way. And then we can see on the bottom there where I'm forming that resistor voltage divider. I got 2 1K ohm resistors, so that's where we get the 500 ohms from. And then that makes a voltage divider with a thermistor and ground, and the ADC just intersects between them to get the reading. And then so that pretty much covers all the STM32 connections. We got the PWM, ground, ADC plus 3.3. That's it. We got the thermistor coming out, 2 FET modules right there on the top, and then one of them is going to be for the motor on the top there, then the second one is for the heater block, and then all that's left is the plus 12 and ground that goes to the power supply. So this concludes the video. I hope that it was helpful in any way to anybody. Hope you enjoyed, and have a good day.